Hi, I'm Eric Lundeen, editor of TPJ, the Tube and Pipe Journal, and also the host of TPJtv. Today we're at McCormick Place at the FabTech Expo to discuss cutting. I'm here with Mike Rupenthal of Omax to discuss waterjet cutting of tube and pipe.
Hi Eric, how are you today?
I'm fine, thanks. How are you?
Great.
Good. You're probably aware that most tube and pipe is cut at the end, a typical end cut, but oftentimes if you need a more intricate cut, you need a more intricate tool, and that's what we're here to talk about.
That's right, we're here to talk about waterjet, abrasive waterjet to be precise. We recently introduced a new capability to our waterjet systems, and as far as we're aware, we're the only company that's offering this today. We've introduced a Rotary axis, which allows us to handle round and square tube materials on an abrasive waterjet. So we're able to do all the benefits of waterjet cutting, which is versatility of materials. Waterjet's indifferent if it's stone, stainless steel, mild steel, iron, composite, plastic. Whatever material you can think of can be cut on a waterjet. So that applies to any type of material that a piece of tube might be made out of. Waterjets cut without heat. They leave a nice, clean finish. And I'll point this out right here. This is an example of the type of finish that the waterjet leaves. There's no burr on here. There's no dross, and there's no heat affected zone. So those are some of the attributes of waterjets. Waterjets are a relatively easy to use machine tool, and one of the reasons is the software that we and other waterjet manufacturers have developed, and I'll get into that a bit later. But certainly some of the applications for this waterjet range from these examples of some of these pipes that we have displayed here in the booth, Eric. You can put these nice bevel angles on the end of a pipe. If you're mating this, let's say at an angle with another pipe, you can put some of these angled holes in the pipe itself right here as an example. This is with the addition of a rotary and a 5-axis cutting head.
Okay, so with the rotary and the 5-axis cutting head, how many axes do you get then?
You get 6 axes then.
6 axes, okay.
Correct. So other things that can be done with the rotary are, for example, this is a ring that we cut out of a piece of stainless steel tubing. You can see some of the intricate detail. We can get even finer than that. This is part of a stent, and we can get even more detail than that with the waterjet. So Eric, right now we're waterjet cutting this tube material. You can see we've got a 5-axis cutting head, so it's able to angle. It's able to do some of these holes that I was talking about earlier.
Okay.
We're cutting submerged here, although it's not necessary. We highly recommend it because it keeps the noise down. The jet is moving at multiples of speed of sound, so it's a supersonic jet. So it can be quite noisy when it's exposed to air. So at least our company offers machines that have water level control, the ability to raise and lower the water level. We do that for 3 reasons, really. We do it for the first reason to keep the noise down. As you can hear, it's relatively quiet when the water level is up. When the water level is down, it's a very noisy process. We do it to keep the splash down. That's what you can see happening right here. Occasionally when it pierces, you'll see the water come out of the either end of the tube. We've got a tube that's about 12 inches long here. So the water that we're squirting through the hole that we're creating is coming out either end of it. And the third reason that we use underwater cutting is it helps keep the surface finish from frosting. Because right at the periphery of any waterjet, abrasive waterjet, there are little stray particles of abrasive.
And this is a result, a piece with burr-free edges, intricate cuts, and no heat affected zone.
Some of the reasons people use waterjet is that no heat affected zone, that burr-free edge. The capital investment required to have a tube cutting waterjet can be less than alternate processes. It's also a very versatile machine as well. So if you need to do some flat stock cutting, the same machine that can do rotary cutting or tube cutting can also be used to do flat stock cutting. As a matter of fact, a couple of our customers that we have in the Gulf Coast area that do tube cutting for the oil and gas industry use the same machine in the latter half of the day to cut big, thick plate steel that they use in their products as well. So it's a very versatile process, and that's one of the primary reasons people do choose waterjet.
Excellent. What's the maximum thickness of material, either in tube or plate, that you recommend cut with a waterjet?
You know, the maximum thickness that we can cut is up to 10 inches thick, and there's a piece over here that we can show you later that's 10-inch thick material. Most waterjet cutting is done in thicknesses of less than 2 inches thick. It's about 80%, and that's a survey of about 600 or 800 users worldwide. But waterjet is a very capable process and will go almost as thick as you'd like it to be. And it does that in very hard materials such as Inconel, Hastelloy, titanium. Again, the waterjet is indifferent to the material that's underneath it.
So let's talk about some more applications.
Well, as I said earlier, the oil and gas industry are big users of abrasive waterjet for tube cutting. We've got medical customers that are using waterjets for tube cutting. We've got jewelry manufacturers that are using waterjets for tube cutting. Probably one of the faster growing applications of the abrasive waterjet is test specimens at pipe mills and people that use that are testing filler metals and welding. An example is this dog bone that one of our customers used, of course, that allowed us to do a test specimen, dog bone, out of this piece of welded pipe here. This allows them to test the integrity of the welding material and the integrity of the material. And the reason they use waterjet as opposed to, they used to do this with a saw. Obviously the saw was much slower, it wasn't capable of making this intricate a shape, and they can't do a thermal cutting method because it changes the metallurgical properties of the material. Waterjet, of course, doesn't do that.
Very important not to change the material properties when cutting a weld coupon.
Exactly. Eric, as I said, one of the reasons that people do tend to use waterjets is they're relatively easy to use versus other cutting processes. One of the things that makes them easy to use is the software that powers them. This is an example of a parametric shape library we have built into our software. It allows you to take 2 pipes of different diameters or 2 pipes of the same diameter, specify the angle that you want those 2 pipes to join, and it takes care of cutting the fish mouths and the other angles that are required for those 2 pipes to go together. All you have to do is specify the tube diameter, the hole diameter, the angle that you want those 2 to go into, and then what quality of finish you want, which is how rough you want the edge, and the software pretty much takes care of the rest.
I'm Eric Lundeen, editor of TPJ and host of TPJtv. Thanks for watching.